Module 4, Graphs and Relations. Question 1. The graph below shows the depth of water in a sea bath from 6 a.m. to 8 p.m. Part A. What was the maximum depth in meters of water in the sea bath? From the graph, we notice that the highest value here is 2 meters. This question is worth 1 mark for the correct answer. Part B. The sea bath was open to the public when the depth of water was above 1.5 meters. Between which times was the sea bath open? Let's draw a line at the depth 1.5 meters. We are interested in the values above this line. And these values occur between 8 a.m. and 6 p.m. So the sea bath was open between 8 a.m. and 6 p.m. This question is worth 1 mark for the correct answer. Question 2. A swimming race is being held in the ocean next to the sea bath. From the shore, competitors swim 500 meters out to a buoy in the ocean and then return to the shore. One competitor, Edgar, reaches the buoy after 12.5 minutes and completes the race in 25 minutes. The graph below shows his distance from shore in meters t minutes after the race begins. Part A. What distance in meters has Edgar swum after 15 minutes? For the first 12.5 minutes, Edgar swam 500 meters. On the way back, he swam 500 minus 400, which is 100 meters. So the distance is equal to 500 plus 100, which is 600 meters. This question is worth 1 mark for the correct answer. Part B. Let E be Edgar's distance from the shore in meters t minutes after the race begins. The linear relation that represents his swim out to the buoy is of the form E equals KT, where t is the time between 0 and 12.5 minutes. The slope of the line, K, is the speed at which Edgar is swimming in meters per minute. Show that K equals 40. The slope, K, is equal to rise over run, or distance over time. That is 500 divided by 12.5, which is equal to 40 as required. This question is worth 1 mark for the correct method, including the correct answer. A second competitor, Zlatko, began the race at the same time as Edgar. Below is the relation that describes Zlatko's swim, where Z is his distance from the shore in meters, t minutes after the race begins, and F is the time it took Zlatko to finish the race. Part C. The graph below again shows the relation representing Edgar's swim. Sketch the relation representing Zlatko's swim on the graph below. Let's start with the first branch of this function. For time between 0 and 10, Z equals 50t. When t equals 0, Z equals 0. Notice that this point is an open circle because this point is not part of the domain. When t equals 10, Z equals 50 times 10, which is 500. So we have a second point with coordinates 10 and 500. We can now draw the first branch of this function. For the second branch of this function, we are going to use Z equals negative 62.5t plus 1125. When t equals 10, Z equals also 500. So this is the first point. We now calculate the intercept with the horizontal axis. So we let z equals 0. 0 equals minus 62.5t plus 1125. We solve this equation for t, and t equals 18 minutes. So we have a second point, 18 and 0. And here is the second branch of this function. This question is worth 2 marks. Each mark would be for each correct branch. Part D. How many minutes after the start of the race were Zlatko and Edgar the same distance from the shore? This happens when the two lines intersect. The line with equation E equals 40t and the line with equation Z equals negative 62.5t plus 1125. To calculate the coordinates of this point of intersection, we solve the equation 40t equals negative 62.5t plus 1125. So t equals 10.98 minutes. This question is worth 1 mark for the correct answer. From the 2017 VCAA examination report, this question was not answered well. A common incorrect answer without working was 11, likely due to rounding to the nearest minute or reading from the graph. Question 3. Lifeguards are required to ensure the safety of swimmers at the sea bath and beach. Let X be the number of junior lifeguards required and Y the number of senior lifeguards required. The inequality below represents the constraint on the relationship between the number of senior lifeguards required and the number of junior lifeguards required. Part A. If 8 junior lifeguards are required, what is the minimum number of senior lifeguards required? For this, we are going to substitute 8 into constraint 1. So y is greater than or equal to 2. The answer to this question is minimum number of senior lifeguards is 2. This question is worth 1 mark for the correct answer. There are 3 other constraints as shown below. Part B. Interpret constraint 4 in terms of the number of junior lifeguards and senior lifeguards required. X plus y is greater than or equal to 12, which means there must be at least 12 junior and senior lifeguards in total. This question is worth 1 mark for the correct answer. The shaded region of the graph below contains the points that satisfy constraints 1 to 4. All lifeguards receive a meal allowance per day. Junior lifeguards receive $15 per day and senior lifeguards receive $25 per day. The total meal allowance cost per day for the lifeguards is given by C equals 15x plus 25y. Part C. Determine the minimum total meal allowance cost per day for the lifeguards. There are 3 corner points, 6 and 6, 8 and 4, and 16 and 4. Let's start by checking the point with coordinates 6 and 6. So C equals 15 times 6 plus 25 times 6, which is 240. We are now going to check the point with coordinates 8 and 4. So C equals 15 times 8 plus 25 times 4, which is 220. We are now going to check the point with coordinates 16 and 4. So C equals 15 times 16 plus 25 times 4, which is 340. So the minimum is C equals 220. This question is worth 2 marks. 1 is for the correct final answer and 1 is for the method. Part D. On rainy days, there will be no set minimum number of junior lifeguards or senior lifeguards required. Therefore, Constraint 2 and Constraint 3 are removed. Constraint 1 and Constraint 4 are to remain. Now, let's draw these two constraints on the graph. The total meal allowance cost per day in dollars for the lifeguards remains as C equals 15x plus 25y. How many junior lifeguards and senior lifeguards work on a rainy day if the total meal allowance cost is to be a minimum? Write your answers in the boxes provided below. There are two corner points, the ones with coordinates 0 and 12 and 9.6 and 2.4. Since we need integer values, we are going to use the point with coordinates 9 and 3 instead of 9.6 and 2.4. So let's check the first point, 0 and 12. The cost is going to be 300. If we check the point with coordinates 9 and 3, the cost is going to be 210. So the minimum cost is $210. So the numbers that we need in the two boxes are 9 for junior lifeguards and 3 for senior lifeguards. This question is worth 1 mark for both correct answers. From the 2017 VCAA examination report, this question was not answered well, although most students recognized the need for integer solutions. 10 and 3 was a common incorrect response. And here is the end of the solutions to the 2017 VCAA Further Mathematics Written Examination 2.